Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm up on the two sample t-test. All right, which we have not even gone over yet, but you know so much about one sample t-test that you can actually get a good start on this. So San Antonio has more than 90,000 adults who smoke. So this is my population, and I'm going to population, and I'm going to put S for smokers who smoke cigarettes. I'm going to highlight that so that it stands out to me. Population of smokers and approximately 1.5 million who do not. So 1.5 million, this is my population of non-smokers. So NS. The UT Health Science Center took a random sample of 36 smokers. So, okay, there's random sample. And we know that our sample for smokers is 36 with a mean resting pulse rate of 85 beats. So we have 85 beats per minute for X bar for this group is for our smokers is 85 and a standard deviation of 17 and a standard deviation is 17. All right, and that's for our smoking group. A separate random sample, hey, we got another random sample of 32 non-smokers. So this is my non-smoker group. So N is 32 for the non-smokers. Had a means of 77 beats per minute. So my X bar is 77 and a standard deviation of 11. So that's my non-smokers. Test and a hypothesis at 5% to determine whether smokers have a higher, that's going to be a key word, smokers greater than non-smokers. All right. So what's our information that we have? Well, we have a sample X bar of 85. We have a sample standard deviation of smokers of 17, and we have a sample size of 36. We also have a sample of 77 for beats per minute for non-smokers. Their standard deviation is 11 beats per minute, and we had a sample size of 32. Our equations up here, so we just plugged in 85 for the X1 and 77 for the X2, smokers minus non-smokers. All right. Then we had 17 for S1, 11 for S2, and our sample sizes of 36 and 32. So we just plugged into the formula. All right. So when we do write the parameter, we're going to have to write one for each one. Let mu equal the true population mean resting pulse rate of smokers. So that's what we called mu1. Some people might want to call it mu s, and that's fine. And then over here, we could call it let mu t equal the true population mean of non-smokers. So we have smokers and we have non-smokers. And instead of mu2, if you wanted to, you could call it mu n for non-smoker or mu ns. But I would use mu1 and mu2 just because it makes it easy. But if you want to use smoke s and non-smokes, that's fine as long as you define it. Well, our conditions. Well, the first condition is the same as before. We have to have a random sample. Actually, we have to have two independent random samples. All right. So do we have two independent random samples? Well, we have a random sample of 36 and we have a random sample of 32. So random sample 36, random sample 32, and we have it. So, and they're both independent. So we'll just say, hey, we have two independent random samples. We have to check the N is less than 10% for both. Well, when I go 36 times 10, I get 360, but my population was 90,000. So N is less than 10%. And also N is less than 10%. Now, what we can do, since it's less than 10% both, is you could say both samples are less than 10% of the of their populations. All right. And then our sample size of 36 is greater than 30. This is a normal population by CLT and normal population by CLT. Real important that you include that CLT. All right, so it's normal by CLT on both of those. Okay. All right, so that's our warm up. That's also in the note spiral. Thanks for watching. Look forward to seeing you on the next one.